Our final video on slope will now deal with an application problem, so we can see how this uh, working with slope will come into a word problem, and you could see it in that form as well. So in this example number 4, we basically have a home repair manual giving us an idea of how far up a ladder should go up a wall. And the wall is at least 1/4 of the height where the top of the ladder hits the wall. So a ladder hits the wall at a height of 12 feet and should have a base 3 feet from the wall. So it says find the recommended slope. And so if we look at our solution for part A, we're going to use just a quick visual, if you will, where we can actually get an idea of what this looks like. And so if we have a wall, and then we have the ground, and then we know that we basically have a ladder here that has a rise of 12 feet up the wall, and that the ladder should be 3 feet from the base. And so of course this would be our rise, and this would be our run based off the given information. And so if we wanted to find the maximum recommended slope, we would do rise over run, which would be 12 over 3 equaling to 4. So that's just a visual idea of what slope looks like. Now it says find the minimum distance a ladder's base should be from the wall if you need the ladder to reach a height of 20 feet. And so now if we're going to go up the wall a little bit higher, that means we need to come out away from the wall a certain amount as well to keep that 12:3 ratio, if you will. And instead of really using 12:3, what we can do is we can use 4 over 1. And so then we can come up with a proportion. So some of y'all may remember proportions from Algebra 1. You can see in Part B's solution we set up a proportion of 20 over x, and x is representing the distance from the wall, equals 4 over 1, and then we're going to use cross products, or what you may know as cross multiplication, thus giving us a value of 5. And so we should really be 5 feet away from a wall to safely be 20 feet up the height of the wall. And so that's a good basic application problem. So let's take a look for one for yourself. So sample problem 4. Why don't you go ahead and pause the video and take a little time to work this problem and see if you can figure it out. Okay, so coming back here to sample problem number 4, we can see that the roof rises 5 feet, and so we see the word rises, and that's pretty clear. And this says over a horizontal distance of 15 feet. Now this is a little less clear, and so what we're dealing with here is a horizontal distance. What that's really referring to is the run. Remember, run is the horizontal back and forth, and the rise is the vertical. And so it says find the slope of a roof. And so our slope is just going to be, if you remember, rise over run. So that makes this very simple. We have a rise of 5 feet over a run of 15 feet. Now we should always get in the habit of reducing our improper fractions, and so we can see we have a slope of 1/3. Now, say we're in the construction business and we need to rebuild this roof with a slope of 2/5. But it's still going to have a horizontal distance of 15 feet. Again, remember, that's representing our run. We want to know what the rise of the roof will be. So what we're really concerned about is we have a run of 15 feet, but we don't know what the rise will be. And we need to make this equal to our new slope. And so we set up a proportion here. And then now we just need to use cross products or cross multiplication to figure out the value for x. So we're going to say 5 times x is going to equal 2 times 15, which is 30. And x is going to equal to 6. And so if we look at what we were trying to figure out, that was the rise of the new roof. Okay, and that's just a simple word problem using slope.